Very well. On page 3, we have another and a different experiment. In page 3, the experiment says, here you have actually just a die and you roll that die. Example. In this experiment, we roll a die. So the question says, first of all, what is your sample space? Sample space. What is our sample space in this case? So let us answer it right now here. You have a die and you try to just roll it. It has 6 sides. You might have 1. The die might end up with the side that has number 2, or 3. It might be 4, 5, and finally 6. Remember that for a sample space, you use curly brackets. So S, or the sample space, is the set, including all possible outcomes. 1, 2, 3, 4, 5, comma, 6. What's the cardinality of the sample space? 1, 2, 3, 4, 5, 6 elements. So the cardinality or the size of your sample space is nothing but 6. Note that you just rolled it once. Part B of the question is, what's the event of rolling a 5? The event of rolling a 5. So remember that we define an event to be a subset. Let us use a capital letter like E representing this event. Event E is equal to the set including 5. If we take a look at the Venn diagram of this sample space, now 1, 2, 3, 4, 5, and 6. We just take a small portion of this sample space, which is here, and we're forming a subset, which is the definition of our event. What's the cardinality of this set? N of E is equal to actually just 1. Very well. Part C says, what's the probability of rolling a 5? So let us write it here. C, what is the probability of rolling 5? Very well. Remember that. We talked about the classical probability. The probability of event E is defined as we have to form a fraction. On the numerator, we're going to have the cardinality or the size of event E. And on the denominator, we have the cardinality or size of S. So what's the cardinality of event E? The cardinality or size of event E is 1. The cardinality or size of your sample space is equal to 6. This is the probability of rolling 5. Part D of the question is actually asking you to find the probability of a number actually less than 5. So let us write it here. This is D. What is the probability of rolling a number less than 5, below 5. So how many numbers are less than or below 5? So it can be 1, or it can be 2, or it can be 3, or it can be 4. So what is the probability? How do we calculate the probability? Actually, in this case, you have 2 options. Why is that? You can either consider the numbers less than 5, or you can simply say that, hey, I know the complement of this set is the set including 5, 6, greater than or equal to 5. So note that the complement of the set 1, 2, 3, 4 is the set, the complement. Remember the definition of complement. If you have U as the universal set, and if A is a subset of U, then A prime, A bar, A complement is the set of all elements such that X is not a member of A. So the complement of this set is the set including elements that are not in this set. So where are they? They belong to the sample space. The set including 5, 6. So the complement of set 1, 2, 3, 4 is the set including 5 and 6. Well, how do we use these to find the probability of rolling a number less than 5? So what's the cardinality of this set? The cardinality of this set, the size of this set, let's call this set set F, event F. The cardinality of F is equal to 4. So you might say, hey, the probability of event F is the cardinality of F divided by the cardinality of your sample space, which is 6. So you get 2/3. Now I want you to think about the complement of set F. So this is set F, its complement F prime. What's the probability of F prime? The complement of F. The probability of F prime is the cardinality of F prime, which is 2. This is the probability. The cardinality of F prime divided by the cardinality of your sample space, which is 6. What is the relation between 2/6, which is 1/3, and 2/3? Very well. Think about it this way. 1 or 100% minus 1/3, the probability of the complement gives you, sorry, this is 3. So since they have different denominators, you can take the common denominator, which is 2/3, the outcome that you have here. So sometimes it's easier to actually calculate the probability of the complement, subtract it from 1 or 100%, and have the probability of your event. The formula that we're going to use is for an event E in sample space S. So a nice formula for you. For sample space S and an event like E, the probability of event E is equal to 1 minus the probability of its complement. Or if you add the probability of the complement to both sides, you get the sum to be equals to 100% or just 1. Another example for you. Very well. In this example, we have a jar. We have a jar. In this jar, we're going to have 14 black jelly beans. So 14 black jelly beans. You have 8 red jelly beans. So 8 red jelly beans. And you have 13 yellow jelly beans. 13 yellow jelly beans. And finally, you have 5 green jelly beans. 5 green jelly beans. So the question says, find the probability that when you take one jelly bean outside the jar, the probability is red or yellow. So when you take out one jelly bean from the jar, find the probability that it is red or yellow. What is the probability? Very well. So you have a jar. It includes these jelly beans. So you're taking out one jelly bean and you want to check to see what's the probability that jelly bean is red or it is yellow. This is the probability that we're looking for, the probability of a compound event. Jelly bean is yellow or it is red. Remember that or actually translates into union. What's the probability of you have a yellow jelly bean or you have a red jelly bean? How do we calculate the union? Recall that when you have a union B and we want to find the cardinality of A union B, this is equal to the cardinality of A plus cardinality of B minus the cardinality of their intersection. Do you have an intersection here between yellow and red jelly beans? Of course not. So the probability is equal to probability of having a yellow jelly bean or probability of having a red jelly bean. What is the probability of a yellow jelly bean? So yellow, you have 13. 13 out of how many? If you add these all together, 22, then you have 35 and you have 40. 13 divided by 40 plus the probability that that jelly bean is actually red, 8 out of 40. Since they have the same denominator, you write one denominator and you add the numerators. Here you get 21. 21 out of 40. You could say that, hey, since there is no intersection between these jelly beans, yellow 13, red 8, the sum is actually 21. So it is 21 out of the sample space. The cardinality of your sample space is equal to 40, and this is the outcome that you have. Again, note that there is no intersection between yellow and red jelly beans. So in this case, you can say that since the intersection between these two sets is empty, there is nothing in it, the cardinality that we learned is equal to 0. Well, on page 4, you have another example. On page 4, we have a jar contains another jar for you. This jar contains actually 14 black, 9 red, 13 yellow, and 5 green. Let's just use G, jelly beans. You pick a jelly bean. What is the probability that that jelly bean is not red? What is the probability? That a randomly selected jelly bean is not red. So the probability that the jelly bean is not red. So what's the meaning of that? When it's not red, it means that it can be black, or it can be yellow, or it can be green. This is equal to the probability of the jelly bean be black, or yellow, or green. And note that there is no intersection between these. They are not dependent on each other. So what's the probability that the jelly bean is actually black? 14. What's the probability that the jelly bean is yellow? 13. What's the probability that the jelly bean is green? It is 5. So 13 plus 14, 27, 27 plus 5 is actually equal to 32. So this is 32 divided by how many do you have in total? So if you add together, you get 23. 23 plus 13, you get 36, and 5, you get 40. 33 out of 41. Now these options, this probability that your randomly selected jelly bean is not actually correct. Well, the next example actually makes it more interesting. Here you have a pair of dice. You roll the pair of dice and you actually want to find the probability of the following events. So in this example, we actually roll a pair of dice. So before writing the events, I want you to think about the sample space. Sample space. The sample space is actually going to be a collection of pairs, 1 and 1. The first die has 1. The second die has 1 as well. The first die comes up with 1. The second die comes up with 2. The first die comes up with 1. And the second die comes up with 3. So do you see the pattern here? The first die comes up with 1. The second die comes up with 4, 1 and 5, 1 and 6. So now suppose the first die comes up with 2. The second die comes up with 1, then 2, then 3, then 4, and so on. So we're going to write down all the possible outcomes. 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. And we're going to repeat this process. What if the first die has 3? It comes up with 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. What if your first die comes up with 4? Very well. 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, and finally 4 and 6. Very well. What if the first die comes up with 5? 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6. But the first die is actually 6. So 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. Well, this is your sample space. What is the cardinality of your sample space? How many pairs do you have? You actually have 36 pairs. So N of S is 36. Very well. So what's the question asking? The question says, so what if you want to find the probability that the sum of the numbers is equal to 2? So part A, find the probability that the sum of the numbers is 2. So very well, we are forming the probability. Something goes on the numerator, something goes on the denominator. On the denominator, you know that the cardinality of your sample space is 36. So you're going to copy this guy here. What are your numerator? Well, the sum is 2. The sum of 1 and 1 is equal to 2. Do you see any other pair? The sum is equal to 2? No. This is the only. So this event has only one member. So the cardinality is 1. 1 out of 36. Well, part B says the sum is equal to 5. The probability of sum of the numbers is 5. Is 5. Again, you're working with probability. You have to write the fraction. On the denominator, you have 36. What goes on the numerator? The sum is 5. So let us find all of those pairs. 1 and 4. So here you have 2 and 3. We have 3 and 2. We have 4 and 1. The sum must be 5. 4 plus 1 is 5. What else do we have? We have, let's see, let's look for all of them. Do you see anything else? The sum is equal to 5. I don't see anything else. Here you have 1, 2, 3, 4. That's it. Yes, it seems like this is it. 1, 2, 3, 4. 4 out of 36. You can simplify that. You can get 1 divided by 9. 1 out of 9. And finally, the last part says, find the probability that the sum of those numbers is actually 7. See? The probability that the sum of the numbers is 7. 7, the sum is 7. So let's use a different color here. The sum is 7. Okay, 7, I'm looking for all the possible ones. 1 and 6. 2 and 5. What else do you have? 3 and 4. 4 and 3. 5 and 2. 6 and 1. Is that it? I think so. So 1, 2, 3, 4, 5, 6. 6 out of 36. 6 out of 36. Or 1, 6. This is your probability. So here's a question for you. What is the probability that you're actually having 10 or you're having 8? That's the next question. So, question. What is the probability of having two numbers that their sum is 8 or 10? So the probability of the first event union with the second event. So do they have any intersection? You should be asking that question. So here you have the probability of two events and you're finding the union between them. Remember that OR translates into union. The probability of the sum is 8. What are the numbers with sum 8? So let's look for all of them. Sum is 8. Very well, here I have 2 and 6, so this is one of them. 2 and 6, I have 6 and 2, I have 5 and 3, I have 3 and 5. What else do we have here? That's pretty much it. So the sum is equal to 8. What about the sum is equal to 10? So the sum equals to 10, you're actually working with 5 and 5, 5 and 5, 6 and 4, 4 and 6. So here you have 1, 2, 3, 4, 5, 6, 7, 7 out of 36. There is no intersection between these two sets. So remember that the intersection is empty. The cardinality of empty set is equal to 0. So this is the probability that the sum is either 8 or it is 10. Well, there are many online simulators that you can use to actually roll 2 dice. So let us reset this. We're going to just roll these 2 dice once. We can repeat this one more time. We can repeat this. We can continue repeating, rolling these 2 dice. And actually, you are seeing these bars actually showing the sum of the values that you're getting. The sum is 2, the sum is 3, the sum is 4, the sum is 5, the sum is 6, 7, 8, 9, 10, 11, 12. You can repeat this 10 times, 100 times, 10,000 times. In this case, we say that the shape of the distribution, the shape is symmetric. Later on, in next chapter that you're talking about statistics, we're going to talk about these types of distributions more. You can actually add more dice, like 3 dice, and then just try to roll them. As you can see, the sum of these numbers, 3 plus 2 plus 1 is 6. So 6, the sum came once. You can repeat this. The next one, the next sum is actually 6 plus 1, 7 plus 2, 9. Repeat it once. You can repeat it one more time. Repeat it as many times as you want, or you can use rolling the dice 10 times, well, 100 times, 10,000 times, and as you can see, the shape is still a normal symmetric distribution.